Question 15.5 says, identify the number of signals expected in the proton NMR spectrum of each of the following compounds. So if we start with A, you can see that it has OMe, and by now you should know that Me stands for a methyl group, so this is a methyl group, and you would remember that the 3 protons in a methyl group are always equivalent. So that's going to be one signal, so we have one. Also, you'll notice that there are no chiral centers in the molecule, and another rule that we looked at was that the 2 protons in a methylene group will be equivalent if there are no chirality centers in the molecule. You'll also notice that there's no axis of rotation in this molecule. So therefore, the 2 methylenes, this methylene and this methylene here, those are going to produce different signals. So now we're up to a total of 3. You've probably also noticed the 2 methyl groups off of these ethyl groups here. So the 2 CH3s highlighted in purple here, these are also going to produce unique signals for the fact that they're methyl groups and they're not identical because there is no axis of rotation in the molecule. Furthermore, the 6 protons that I've highlighted in red here on the aromatic ring, so if I was to replace each one of these hydrogens with the deuterium, you would see that you would get 3 different compounds. Therefore, the total number of signals would be 1, 2, 3, 4, 5, 6, 7, and 8. So I have a total of 8 signals in this molecule. Moving on to B, you can see that there's an axis of symmetry through the molecule right down the middle like that on this blue line. So therefore, these 2 protons that I'm highlighting in blue, if you were to do the replacement test with both of those, you would see that you would get an identical compound. So therefore, these 2 protons are chemically equivalent and would produce the same signal. Also, these 2 protons here are chemically equivalent based off of reflection. So they would both produce the same signal. I also have 2 methyl groups. So I have a methyl group down here, and then of course I have this methyl group up here. They are not the same because one of them is attached to the oxygen, the other one is coming off the aromatic ring. So the total number of signals that I'm going to have in B are going to be 1, 2, 3, and 4. So I'll have 4 signals for this molecule. In C, you can see that there's 2 axes of symmetry going through the molecule. So that means that each one of the protons attached directly to the aromatic ring, all 4 of those are going to be identical and produce the same signal. Also, the 2 methyl groups, based off of symmetry, they're going to give the same signal. So I only have 2 signals in this compound. So I have 1 signal for the 2 methyl groups, and then I have another signal for all 4 protons that are directly attached to the aromatic ring, which are all chemically equivalent. So in C, I have a total of 2 signals.